So just wanted to get that little clip in. We're going to be talking about two articles coming out of Sky&Telescope and phys.org about the same object, WOH G64, a massive star heads into the danger zone. So as I just played, Kenny Loggins in the song Danger Zone states in the lyrics, highway to the danger zone, going to take it right into the danger zone. We're going to go right into the danger zone today, a possible danger zone coming up. It's not really a danger for Earth, so don't freak out and don't let anybody try to tell you this. But we're going to, for decades, WOH G64 has held a very prestigious, if terrifying, title. It's one of the largest stars ever discovered. It's located about 160,000 light years away, so it's never going to impact Earth. But it's in the Large Magellanic Cloud. This behemoth of the south is so large that if it was placed in our solar system, its outer layers would reach out past the orbit of Saturn. However, two reports, like I mentioned, in Sky&Telescope and phys.org, suggest that WOH G64 is no longer the star it used to be. Kind of went on a diet. It's currently undergoing a metamorphosis that astronomers believe could be a final warning from a catastrophic supernova event that could be coming. So, the setting, dimming, and shape shift. The primary discovered, detailed by Sky&Telescope, and I have a link right there for it. So if you go to Easy Astronomy and look at the article, you can get the link to it. Is that WOH G64 has dramatically faded over the last decade. Using the European Southern Observatory's Very Large Telescope Interferometer, the VLTI, astronomers captured the first ever close-up image of a star outside of our galaxy. And you can see that in that image that's at the top of the article right there. What they found was shocking. The star has shed a massive amount of its outer layers. This gas and dust have formed an egg-shaped cocoon around the star. It isn't just a minor burp. The star has lost enough mass to fundamentally change its appearance, transitioning from a classic red supergiant into something much, much more unstable. Based on research and astronomical theories presented in these reports, there are two primary scientific explanations for why WOH G64 is dimmed so dramatically, possibly a third too. We have the dust shroud hypothesis, which is surface mass ejection. The most likely reason for the dimming is that the star coughed out a colossal amount of its outer layers. In massive stars like WOH G64, radiation pressure becomes so intense that it can literally push the star's atmosphere out into space. As this expelled gas moves away from the hot star, it cools and condenses into a solid microscopic particles, essentially cosmic soot or dust. The result is the dust forms an opaque cocoon or shell, the egg-shaped structure mentioned in the VLTI image above, that acts like a thick celestial curtain. It absorbs the star's visible light and re-emits it as infrared heat, making the star appear significantly fainter to optical telescopes, even though the star itself remains just as luminous behind the veil as it was before. Another possibility is there's been a significant drop in surface temperature. The internal evolutionary shift where a star's surface temperature has plummeted. As a red supergiant approaches its end, its outer envelope can expand even further, becoming even more bloated and cool in stellar terms. According to Wiren's law in physics, a star gets cooler. As a star gets cooler, the peak of its light output shifts from visible wavelengths to infrared. The result, if WOH G64's surface temperature dropped by even a few hundred degrees, a huge portion of its light would disappear from the visible spectrum that we see with our eyes or standard cameras, shifting instead into the deep infrared. This would make the star look like it is fading away, when in reality it's simply changing the color of the energy it's releasing as its internal engine begins to fail. In addition, the internal changes in dust shroud, both articles explore a third, highly intriguing possibility, the presence of a hidden companion star. While WOH G64 has long thought to be a lone behemoth, recent data suggests it may actually be part of a binary star system like most stars in the universe are. The pull of a partner, astronomers have detected evidence of a second, much smaller and hotter bluer star orbiting the red supergiant. The companion is likely exerting massive gravitational tidal forces on WOH G64. This gravitational tug of war is essentially stretching the red giant's outer layers out of shape. That explains the unusual egg-shaped cocoons seen in the VLTI images. The dust isn't expanding evenly in all directions because the companion star is pulling it into an elliptical or donut-like torus. The companion may actually be siphoning gas off the larger star. This turbulent transfer of material creates extra friction and heat, which produces the strange emission lines in the star's light spectrum that originally led some scientists to think the star was going to explode. If this theory is correct, WOH G64 just isn't dying of old age, it's being harassed by a smaller partner. This interaction can mimic the warning signs of a supernova, making it look like the star is on its deathbed when it might actually have a few thousand years left to go. Only time and further observations will reveal if this is the case. According to phys.org, and the links there to that article, this transformation is rare because humans have never witnessed a star of this magnitude in its final pre-supernova state. Most stars take millions of years to evolve, but WOH G64 is changing on a human timescale. The star's light profile has shifted significantly, suggesting the internal nuclear engine is struggling. Astronomers describe the star as being ready to blow, as it is likely moved into the final stages of core collapse preparation. The egg-shaped dust shell is a smoking gun showing that the star's gravity can no longer hold onto its bloated outer atmosphere. Why does it matter? This isn't just about a star getting dimmer, it's about the physics of the extreme. These two articles highlight several key takeaways for the space community. The first, extragalactic stellar close-up. We now have the technology to see the shape of a star in another galaxy. That's awesome! A feat that was impossible just a few years ago. By studying WOH G64 now, scientists hope to create a profile of what a star looks like right before it dies. This could help us predict when other giants like Betelgeuse might finally explode. The massive dust cloud WOH G64 is currently creating will eventually be seeded back into the universe after that explosion, potentially forming new planets and stars millions of years from now. WOH G64 is currently in its death throes. Whether the final explosion happens tonight, tomorrow, or in thousands of years, we are witnessing a once-in-a-lifetime transition of one of the universe's true titans. As the articles conclude, we aren't just watching a star transform, we are watching a cosmic landmark disappear. And that's significant. Hope you found this interesting. Hope you take the time to look at the articles. Thanks for joining me. We'll catch you next time.